As I said, hello and good morning, everyone. Uh, we have a few minutes past 10 already, so hopefully everyone is joined, or if not, they will join us soon. Um, as you saw from the video, today we have a webinar about the about the possibilities of perforation and emotion or backlighting in metal claddings. Our presenter today will be my colleague Johan, who is, well, an expert in both of these fields and has been working directly with perforation and emulsion projects in our cladding plant in Pärnu, Estonia. Um, Before we start, I would like to say that the presentation will be divided into a few segments, and after each of those, we will have a minute or two to answer your questions. So if you have any questions, please write them down in the chat section so we can see them and answer. I think this is enough from me for now, and let's start with the presentation. So, Johan, the floor is yours.
Thank you, Haraldos. I do hope that you can hear me. um,
Yes, then we can.
yes. Labas rytas, labrīt, tere hommikust, and welcome and glad to have you here. Thank you for joining this webinar, which presents possibilities of Ruukki perforated products. Not just claddings, the same technology can use with sunshades, fences, balconies, and so on. We will cover a few technical details, and also this is illustrated with a lot of examples we have already produced from existing projects. My name is Johan Lassen. I work in Ruukki since 2014 and started as production programmer, which is in general means that converting incoming order for production machinery. After 3 years doing this job in production, I started in January 2017 as a project engineer for special cladding projects. And my work is containing giving internal trainings to Ruukki colleagues, but also consulting and assisting architects, investors, contractors about usage of any kind of Ruukki product. I have a master degree from Tallinn Technical University. My field is power electronics. Previously, I've been working in IT business and manufacturing of industrial electronics, and I've been programming computers for last 30 years. So this experience actually gives pretty much nice possibilities to use this knowledge also in my existing work right now. During my normal job every day, I see situations that a lot of work is done, but it needs a lot of adaptation or rework because some aspects are not considered from very beginning. And this means that longer time for preparation, perhaps unnecessary waste of raw material, eventually like more difficult to produce and so on. And it's, of course, lead times can be related to, and eventually it actually makes a project more expensive. So this training today is to give hints to avoid such situations in some situations. Well, I'm pretty lazy person by myself, so I always try to get things by thinking first and only starting drawing something because yeah, you can easily waste 2 weeks of drawings and only then understanding it doesn't work. So you can often see me with coffee cup around the building, and people think, yeah, everybody knows that I'm lazy. Okay, let's go with presentation. I turn my video off, and Ruukki Emotion is in general set of perforated products in Ruukki company, and we define three basic types of perforations. So the left upper is full perforation, which is actually very rarely used as cassettes you see on photo. And the reason is that it's most cost effective, but the raw material is actually pre-perforated, which means that if we cut any piece of it, we cut it through the holes. And those panels, if we make 100 panels, those are never 100% the same. It would look pretty good from distance, but not if you need really close-up view. Then another type is symmetrical perforation, which in general means that the raw material is actually solid, and the shape of the blank is cut. The same time perforating this front of cassette with some given pattern. And in most cases, we do not need drawings of exact pattern for doing this. And the most interesting looking is art perforation, which in general means that we do take some image, either photo, artwork, clip art, just some random patterns whatsoever, and convert it to AutoCAD file with exact position and exact number of holes in certain positions. So eventually, when this is distributed to cassettes, we can figure out, make pictures like you see on photo. And now the next slide is information about full perforation products. Normally, full perforation is used for design profiles. Design profile is in general S or T type profile, which is produced on coil-fed profiling lines. And the patterns you see on this sheet are actually produced in Ruukki's factory in Vimpeli in Finland. If this is not enough, we do have some sub-suppliers in Finland, in Poland, in Denmark, who can make perforated coils with bigger hole size. I would say we have tested up to 16 millimeter on our profiling lines, not more because there may be surprises. And as you see from Finland, we can get this perforated area percentage of 5 to 40%. In some cases, it's important, for example, for parking halls where airflow is important. And as it was asked always that are we able to make 50% perforation? So we made tests. So we are able to profile this 40% material in this way that ready material has actually 50% of perforation per square meter. Really useful in some cases. So next type is symmetrical perforation. And well, this table here is a little bit related to symmetry. You see that we can achieve this 30% density several ways. Of course, the bigger is the hole, the smaller is number of holes per square meter. And in lower row, you see production time. If we would make it on punching machines, that you see that it's less than 1 minute with 50 millimeter, and it's almost 1 hour per square meter with 6 millimeter diameter. But I will say that from this table, if you use punching machines, so I think somewhere up to 16 millimeters, I will even not try on punching machine because it still takes too long time and needs so much. There will be some issues in production as material is curving during this punching. But there are some ways to make the situation better, like cluster rules, which I will explain in a minute. And here is, this is now exactly about symmetrical perforation. As said, if you order cassettes with symmetrical perforation, uh, on order form, we have the small table like in this red rectangle. And there are shown some variants which you do not need even to ask. So it's safe to use. If you put 12mm diameter and d plus 15 as the distance between centers, then it will work fine. But the main idea of this slide is that if here is set the center to center distance in horizontal and vertical is 40 millimeters. And now if we just put some cassette sizes here, it's visible that the pattern actually deviates, not pattern deviates, but cassette size deviates in way that in some cases we do not have room, 40 millimeter room anymore for next row of holes. So therefore, distance from edges starts to deviate. And if you have situations like these, that the cassette size and perforation are not referring to each other, then we can get some unexpected results. It's always good if cassette size deviates, like if here is 40 millimeter, then cassette size deviates also 40, 80, 160, 400 millimeters. And then it's all aligned. And same happens actually if we need to make brick pattern installation. That if the brick pattern joint is shifted like whatever number, like 500, 500 will be great because it's possible to deduct to 40. But 70, for example, then those lines in pattern are not aligned anymore. And on next slide, there is a good situation. The drawing itself is actually from our perforation project, but those sizes and also center distances in vertical or horizontal are carefully chosen to have this distance from hole to cassette edge, that it's always same 20 millimeter. And it's not necessary to have the center to center in vertical and horizontal exactly the same. It actually doesn't matter, but it must follow the size of cassette. And of course, joints must be also recognized because from edge of hole we need at least 10 millimeter before bend, because the holes which are closer, they will stretch to the edge during bending. So it's same pattern here on this slide, but the visual effect is different. But this is just turned 45 degrees. The leftmost bottom is actually shifted, but the density of the pattern is still the same. The right bottom is actually a triangle pattern, 60-degree triangles, and it has 40%, 14% more holes, so a little bit more dense. And the same as with previous slide, when we rotate pattern, we can also rotate pattern on cassettes. But here has to be recognized that there will be some losses of information on edges. For example, if we turn the pattern not 45 but 15 degrees, for example, then actually we lose a lot of holes because we cannot go closer to cassette edges. We have had similar situation, and as this was not considered before, it was a bit surprise. The same happens when you leave pattern as horizontal and vertical, but you turn cassette layout. For example, if you turn cassette layouts 15 degrees, then you have pretty much similar result as shown here. We can generate random patterns. Easiest is to use round holes. We can also make rectangular or in fact whatever shape holes in predefined sizes and in predefined placement. Usually we do it in a way that we create some space in AutoCAD file, for example 10 by 10 meters, and we can send it to architect. He or she can choose whatever area they like and build the facade of those parts. If it's a bigger project, then it's actually easier to, for example, choose, let's say, 5 areas on certain sizes and just repeat this on facade as a sequence, because it's absolutely less work of preparing 5 cassettes drawings than 100, and then repeating those 5 pieces through production 20 times is no problem at all. On right side, there is a photo from recently finished object in Sweden. It's a shopping mall, Mellerud. The product is Liberto 500, and it's anodized gold. The hole size I remember is something like 50 millimeters, and distance between them is 80, if I recall correctly. Yeah, another random pattern from a project in Norway. We produced mock-up or sample cassettes with those patterns on right, and sent these to architect, and they made a decision to which pattern to use. And this is automatically generated. It's not drawn by hand. Now it becomes to my favorite part, art perforation. The photo on left is not good quality, but it was nice image on my son's T-shirt. So I took a photo and passed it through generation. Our system works in this way that if everything is set correctly, we can have AutoCAD file where right diameter holes are placed in right positions and the image is in scale. So, for example, if we would need this perforated pattern to be 9 meter high, then we can actually preset the exact parameters to get it. And when everything is set, including the sizes of cassette, it's really easy to transfer to cassettes for manufacturing. The image can be whatever. I would not suggest to use portraits much because of. I have some examples in next slide. Here is one example of perforated project in Finland. This picture with guitar has actually a blind background, and it has Emotion 1 backlights, and the rest of facade is actually symmetrically perforated cassettes with no backlight. So this is how it looks in daytime and nighttime. There's another art perforation pattern. This is in Valmiera in Latvia. We generated this image from photo, and there is used 10 millimeter, 15 millimeter, 23 and 40 millimeter holes to create this pattern. It's altogether something around 10 meter high and looks really nice. So example how we can use art perforated products. There is another very airy, it also in Latvia with some national pattern and some company name here. For some reason, it seems that if you use square holes, then these behave better in production. Probably tension in metals is distributed different way, but I think this when we would make this with round holes, it would not be so flat, I believe. And then we can make whatever shape of cassettes, of holes, depending on these are now we can call it as art perforation, but technology is different. That this is actually pure mathematics behind that. If it becomes to project, then we usually estimate the volume and we to acquire special shape tools. Whatever shape tools is possible to get, we just need to design, define what material is used, and but we are able to produce sample pieces without buying any extra tools. It just will take a little bit more time, but as we anyway make just mock-up of 3 or 4 cassettes, and it doesn't matter. And regarding tools, we have some limitation in our production machinery about sizes of tools. But then again, if you look to this triangle pattern on the right side, we may buy tool which size is about the one here in middle, and then just punch 3 times to get bigger hole. So these are pretty much universal. Okay, next. And this is how we need to prepare art perforation. We will need image, what you want to have on your facade. And then we need to have at least some preliminary idea of how cassettes are placed and which are sizes, and then sketch how this must be placed on this layout. And if we have this information, we can actually create either customer gives us what sizes of holes and what distance is wanted, but we can also propose something from us, from our side, which looks reasonable, which looks good looking, and propose several variants. And normally we actually prepare one fragment of this layout to show our capability, that what we're able to do. And later during discussions, we find out the final solution and create full layout of the building. This is a little bit technical now, but the idea of the slide is that how it actually happens. There is something that designers know is called pixel. Pixel is one dot in image. And as this punching in some material anyway is a little bit close to black and white printing, then we need to define how those black and white pixels are arranged. And personally, I do like to transfer those images in a way that the rightmost one is half-toned, means that we have big holes where black area is, and we have no holes where white area is. So by this big hole, we actually need to define the pixel size. For example, if our facade is 4 meters high, and we have pixel size of 20 millimeter, then our image can be 200 millimeter high. And then the hole size cannot be more than 16 because we need some material between holes. In some cases where the area we perforate is very limited, then this middle version becomes useful, because this consists of same size holes, which are just arranged in a way that in dark area we have more holes, in light area we have less holes, in white area we have no holes at all. But understanding this concept actually helps to recognize the bigger this area, then better resolution we have, and smaller hole, but it again increases the price a lot. Cluster tools, which I spoke before, is that the tool that, if you now remember the table I show you with 30% perforation density with different diameters. So this is way actually to help the situation a bit, that we are able to design the tool which hits many holes per one punch. And with this even higher densities are possible. Like I think we have done something like close to 60% densities. This is not very flexible because we can make only this pattern, but in some cases really useful if volumes are big. Next, here is one more example of 1.5 Corten steel made with cluster tools that punches 4 holes in once. Here is example that the cluster tool can be introduced for art perforation as well. This is one project we made for Canada, and one of our existing cluster tools was used, but the edges of those figures are actually filled with single punch tools. Corten steel. There is example of how we can get the bigger perforation intensity. If still very high levels of perforation are needed, then we can, for example, introduce another perforation inside the other. And this is possible also with art perforation. So here is some art perforated pattern with bigger holes, and then we simply put one more pattern of 16 millimeter holes around the whole area. And this is actually adds those necessary 60%. And here is one example of Tallinn Airport parking hall we made in 2018. This is designed in a way that perforation density is not important at all, because design is done this way. It was a nice project consisting 2,200 different components which were assembled on site, because one lamella is some 6 meters high. So now how we can use those perforation on facades. Here is a sports hall in Norway. This hanging climber figure is 6 meters high. So we generated from those images these perforated patterns and placed those on our lamellas. This is lamella lab 60. And below here is one example which is in Latvia. From an architect, we got initial idea of how it should look like. 3 different densities of perforation and shape of cassette. And it was nice cooperation with this architect. We took the idea. First we changed the size of cassette for better utilization of raw material, so less waste. Then we defined again those perforations here, and actually the placement of holes on each lamella is exactly the same, just diameters differ. Really nice project, very airy, I would say. Here are some more. This Apelsins Centrum in Adaži in Latvia. The whole drawing was given by architect. So exact right holes, exact right places, and we just transferred it to production. Yeah, and on the right side here is another project from Sweden. It has also backlighting, and we, according to first sketches, which were actually hand drawn, we created some pattern, mathematically created in AutoCAD, which was produced as sample cassettes and sent to customer, and actually they evaluated it by themselves, and we got back architect's exact drawing already with right holes in right places, so we just converted it. At lower side you see one existing project in Finland. We got this tea leaves image from architect. It was actually exported from AutoCAD file as polyline, and then we converted it back to holes, pattern, and then back to AutoCAD. And later we used the same pattern in our showroom in Pärnu, which is shown here on the right side. These are a few examples which are not possible to do, or at least not reasonable to do with perforation. We can use laser cutting capabilities of sub-suppliers, but not just core 10, but we can also do it in copper, stainless steel, zinc, all not coated materials like natural aluminum. High-arc is actually Ruukki's name for PVDF coating, and laser cutting of those materials is not possible because the laser destroys this coating, but it's still possible to use steel or natural aluminum and powder bait it after if you need some colorful surface. And the last year we introduced production of aluminum composite cassettes. We can also make the different shapes by cutting by routing machine, and also we can make it in punching machine. We have two types of 4mm aluminum composite, and the perforation is allowed for FR material only. And difference of these is that A2 core cannot be exposed to environment. If we need to use A2 core, then for indoors it's okay, but it absorbs moisture, and this is why it's not required. FR material has a bigger consistence of plastic in composition. Okay, and now here is, I do have few questions here.
Yeah, we have a few questions.
Yeah.
First one was if we can fully perforate weathering steel.
Yes, we can, but this has to be done at sub-suppliers, because weathering steel leaves some residues on punching machines and so far we haven't done it in Vimpeli, but in general, yes, it's possible.
Okay.
Either then sheets or coil to coil.
Okay, thank you. And another question is, what computer programs or apps you suggest use for making perforation drawings?
I suggest AutoCAD. Well, but seriously speaking, the system we do to have developed the whole system inside Ruukki. We have different generators, including this what makes art perforation, and those are not public. Regarding sustainability, if you mean warranties of materials are given in our warranty documents, when asked, we have up to C4 class. If I remember correctly, 20 years when it's perforated, 1.2mm material and powder painted. All the rest materials have like natural warranties. Okay, should we continue?
I think yes.
Okay. And now we talk about two different light systems for Ruukki Emotion. That the first one, original one, was developed in 2015, and which in general means that we have lights inside starts, like it's shown here on left side. You see that those starts leave some shades. The start itself is 70mm wide. And as I told before, using portraits on facades. So in this case, we have John Lennon in jail because those form this strange frames around the pictures. The right one picture is our HR manager Inna at some student work show in Tallinn Technical University, and smiling guy left is a mascot of Technical University named Julius. They did like those cassettes so much. There are actually also the Ruukki logo behind her. They did like those cassettes, so we left these at the university, and now those are presented in some students' club. Here are a few examples of light inside studs. It gives really powerful light. The blue image on left is some 16 meter high. We had close cooperation with architect, actually artist, who created this, but we made all drawings of cassettes and all perforations. In the right picture, we got just the idea how those straws have to be placed, and this is different in this way that they're actually perforated background, and those straws are solid. So to consider that, do you want positive or negative image? As on previous slide, where one was positive and the straws actually were negative, meant that it looks nice on nighttime. Do we need full colors or white color? And there is definitely a price difference. What to consider more is that distance from wall. That because the one thing is that the studs need some time, but some space, but also light needs some space for distribution, because the light actually bounces between background and backside of cassette. Joints and studs give shades and also a locking system, and the viewing distance is important in this sense that there's no sense to put very small holes when your viewing distance is very big. I've been involved in project when they asked that, okay, make us perforated company logo with 12 millimeter holes, and it was intended to place on top of 20-meter building. So actually nobody sees that is it 12 meter hole or is it 50 millimeter hole or even bigger. So variants are white light with no control, and white light which is dimmable. Dimmable means that brightness can be changed. And then we have this RGB, red, green, blue, which is fully controllable, can change colors whatsoever, programming different patterns, blinking, whatever. And Ruukki delivery includes all components for control, including power supplies. Documentation, detailed drawings and connection schemas are available. One point here is that in simple cases, we have one small power supply built in each stud. But when project is bigger, like the one you show on those photos from Finland, then in some cases it's reasonable to have one or few bigger power supplies which carefully placed along facade, and this LED supplier actually can take care of this. This is what were our goals when we decided to design this Emotion 2, that it's easy maintainable, because in first case you need to open actually whole facade to make any changes or replacement. It's modular, it's cost effective, expandable, and so on. Some first examples are shopping mall Eden in Tartu. The height of and here actually lamps are hidden in parapet. This part of a building is 6 meter high. On the other side, we have actually 12-meter high facade. I don't know if any of this is visible on this really right side. And still you see that there is enough light, even too much, that also like almost street is lit. And then we have demo wall at Pärnu cladding plant. So this, what we built here in Pärnu, it is 9 meter high. And the idea of this wall was to test, but also to show to customers the different colors, different perforation types, and different products which are available at Ruukki. And lamps, we have two 60-watt lamps here below, and the light aid here at top is actually not the light itself, but it's a reflection from the cover here, which was some light gray color. And in middle here are elements which were used for this demo wall. So this is LED. On photo here is a 1.5 meter module, but we have those also 600, 900, 1.2 meters, and 1.5 meter. The respectively, so power up to 75 watt. We do not have colors with these lamps, but when ordered, then actually it's possible to change white color to, for example, blue one, and you still have it dimmable, so brightness can be changed. But we do not have any color option for this lamp yet. Components is we took our adjustable start, which we have in portfolio SS5, SS6, and we converted it in a way that we made it thinner. So now it's 54 millimeter to block less light in joints. And we made it deep enough that it allows light to follow directly. And it's no problem if one LED lamp covers actually a few distance between starts, because it doesn't leave any shades when light is directed upwards. Here is a component for fixing the lamps on cladding, the special design bracket. Actually, those look pretty same, but those are actually different. That one is when you have lights upward on top, and another when you have lamps at bottom. This is what consists in Ruukki delivery. So all types of those lamps, brackets, tubes, adjustable start parts. One more start, just a moment, I will say why it's for, and a flat sheet, because in some cases when you have dark background, you need to make it lighter. For example, sandwich panel RR40 silver is fine enough background. We have created order form, so just fill it up and send it to us. And this is now cover for this lamp. The idea of it is that it's not in this sense part of Emotion 2, because it deviates, the shape of cassette deviates with each order, because it has to follow with shape and color of facet main cassettes. Side flanges are bent that block light, so you do not see any light leaking through the vertical joint. The bottom is perforated, and there will be visible fixings, because one point of the project is maintainability, that we need to open it every now and then. And now when it's installed, then actually we have full continuous tunnel here. If you open those lower covers, we can access those lamps, replace fixed cables to whatever. And here on left down corner, you see that there is another extra start horizontally. And this is actually the only purpose of this is that we put it, if we use sandwich wall as background, then most likely we need to open it several times during lifetime. And doing this directly to sandwich panel, we will simply destroy sandwich panel by too many holes. So this is why we figured out this solution. Which is dimming, is that this is to change brightness, and this is not actually part of Ruukki delivery, simply because there are millions of different possibilities. You can connect some darkness sensors to it. You can connect it to building a full lighting system. You can, for example, maybe one wants to control it by remote control, or even by mobile phone when it's big site and viewing distance is a very long way ago. But it's industry standard. Any electrician knows and can propose the suitable variant. lamps come with 1 meter cable attached. And again, detailed drawings like of mechanical parts, and connection drawings of different variants are available. On this slide, we have no dimming and dimming variants, and only the lamp always have this dimming option built inside. It just depends on connection, either you use it or not. It can be simply connected in way that you turn it off and turn it on. And there is a different impression, daytime and nighttime. Yeah, here you also use the different color material on wall to see that how much it affects this nighttime visibility. Just for fun, I tried that how it works when we add some colors to it, as we do not actually provide colorful systems. But in this case, we used just films which are possible to get from companies who deal with, for example, musical instruments and stage lighting. There is company Lee Filters in England who makes really high quality, nice films. And if your project is small enough, then it's easy just to open those colors here for one time and, for example, change whole facade to red during Christmas or something like this. Here is one more completed project in Finland, which is now real Emotion 2.0. The thing what we did not know is that we used first time we used our new Liberta 550 cassette on together with a backlight which was installed on top. On top you see there a little leak between those covers, but here is one row of cassettes that can be opened if any maintenance is needed. But what we didn't know is that there will be leaking of light through horizontal joint. So next time we do a similar project, we just need to introduce a few more bends on top of cassettes. And here is an example case of how this Motion 2 is placed on facade. That it depends actually on running meters. Well, in general, yes, it depends on running meters of continuous facade. Need to be made sure that, or to be informed that, for example, those windows here most likely will leave some shades on upwards, and so on. So altogether 50 lamps, and approximate price of lighting project is 25,000 euros. Here is another example of a sports hall in Sweden, Mariahallen. It's a health sport, and we did sell actually Liberta 1 system where the built-in LED start access carrier. But for example, we made a comparison that what it would cost if we were using Emotion 2.0, and we figured out that it would be 54% reduction in price comparing to first one, and both were white. Okay, and this was it. Do we have any questions about Emotion 1 or Emotion 2?
I think you made a very clear presentations because we have no questions regarding the emotion systems.
Okay.
So yes, thank you, Johan, for the presentation. I see someone is typing, so probably just yeah. So this is what I wanted to mention. In the end, actually, the presentation you just saw will be shared with you within a couple of days. And yeah, so all in all, Johan, thank you for this presentation. And of course, thank you all for attending today. I hope you learned something new, saw something new. And just for the end of the presentation, I think I would like to show you one more video clip, which shows us our reference projects. So just a second. And once again, so thank you all and enjoy the clip and have a good day.
Okay, thank you.